Okay, so we're going to talk about, if you missed class, we're going to talk about finding limits analytically. So we did stuff with graphing yesterday, the day before, but now we're doing something with limits with analytically. So analytically, the idea is you're just given some sort of an expression, and you have to figure out what the limit is. So the first thing you're always going to do is try direct substitution. Okay? Because you're going to get three things that might happen. The first thing that might happen is it works and you get an answer. And then you're done. It might just work. You plug a value in and you get an answer. So the idea with direct substitution, just to remind you, is plug in the x value. If you just plug in the x value and you get an answer, you're done. It's simple as that. What you might get is you might get some number that's not equal to 0 divided by 0. And if that happens, that is a vertical asymptote. And if you have a vertical asymptote, that means the answer is either does not exist or infinity or negative infinity, depending on the sign. So you may get something that when you plug it in, you either get does not exist, which is always the safest thing. I mean, if you have a choice to get does not exist, then that's what you should put. If you have to make a determination about infinity or negative infinity, then we have to look at some signs, the sign on the numerator and the sign on the denominator. But if you can choose does not exist, by all means, that's key. The third thing that can happen is you get 0 over 0. And if you get that, that is either a hole or a jump in the graph. It's either a hole or a jump in the graph. And the way you're going to deal with that is you are going to factor or simplify and re-evaluate. Okay, so you might have to factor it, simplify it, and then reevaluate. But the first thing you always want to try is direct substitution. Now, in today's assignment, you're going to get two different things. One is with piecewise functions, and then the other one is with functions that are just built in, like something like those two functions. So let's look at first the piecewise functions. So remembering with piecewise functions, the thing you have to watch out for is you have to watch out for a jump in the graph. So because when that happens, if you get a jump in the graph, when there is a jump, the limit does not exist. So if you get a jump in the graph, the limit does not exist. Remember, but if you have an analytical thing, the first thing we're going to do is we're going to just plug in the value. Because if we're trying to figure out if the limit as x approaches 3 of f of x, what that is, what we have to do is we have to evaluate two different things. We have to evaluate, we need to look at what the limit as x goes towards 3 from the left side of f of x equals. And we also need to look at the limit as x goes towards 3 from the right side of f of x is equal to. And again, we're going to do direct substitution first to see if it works, to see what we get. If we plug in 3 from the left side, we're going to be using numbers that are smaller than 3, which would mean we're going to use the top function of our two functions. So if we do that, we end up with negative 3 squared plus 6, which is negative 9 plus 6, which is negative 3. If we look at the limit as x goes towards 3 from the right side, so a number is bigger than 3, now we're going to use the bottom function. Look at the bottom function. We have negative 9 plus 2 times 3, which is equal to negative 3. Since these two things are the same, the answer is just 3. So the answer to this equation is just 3, negative 3. Because the left side and the right side agree. So since the left side was equal to negative 3 and the right side was equal to negative 3, then we say that since they're the same, then that our limit is negative 3. Okay, so the answer is just negative 3. Hopefully that one makes sense. There wasn't a jump in this graph. You know, the left side equaled the right side. We went from a parabola to a line. We went from a parabola to a line that even if it has a positive slope, we went from a parabola to a line. So hopefully that makes sense. Now, the next question says, take and look at this limit as x goes towards negative 3. But remember, this little symbol right here means from the right side of 3. So that's numbers bigger than, sorry, it's negative 3. Negative 3. So from the right side of negative 3. So numbers bigger than negative 3. Numbers bigger than negative 3, so bigger than negative 3 is this one right here. That's the numbers that are bigger than negative 3 when x is greater than negative 3. So that's the only one we have to look at. So the limit as x goes towards negative 3 from the right side of f of x using direct substitution is negative 3 squared plus 9, which is equal to 18. That's our answer. Okay, so we just do direct substitution. All right, now what if I get equations like this? Look at something like this and I go, okay, well, shoot, go back to the beginning and what did I tell you to do? I said use direct substitution first. So let's look at direct substitution. If we do direct substitution on this, we would look at the limit as x goes towards negative 5 of x squared minus x divided by 5 times x minus 5. If we do direct substitution, we would get negative 5 squared minus 5 divided by 5 times negative 5 minus 5. And if we kind of go through this, we end up with, okay, so this is 25 minus 5 over negative 25 minus 5. So we end up with 20 over negative 30, and we're done. That's a fine answer right there. Doesn't necessarily have to be simplified. You could reduce it to negative 2/3, but that's it. We're done with that one. Okay? So we really we aren't going to do anything else with that. That's just the answer. Direct substitution works. What if we do this one? Now let's do direct substitution. When we do direct substitution on this one, we would kind of go in here and we'd say, okay, well, we put 1 and we square it, minus 1 divided by negative 4 times 1 plus 4. Uh-oh. 0 on the top, 0 on the bottom. That is a hole, because this isn't a piecewise function. There's a hole in the graph at x equal 1. Doesn't mean the limit doesn't exist. It just means there's a hole in the graph. So go back to the directions. What we're going to do is we're going to factor this. What we can do is we can say the limit as x goes towards 1, x squared minus x divided by negative 4x plus 4 is the same thing as writing the limit as x goes towards 1 of x times x minus 1, if I factor out an x, divided by negative 4 times x minus 1, if I factor out a negative 4. Oh, wait a minute. Look what happens there. We get to reduce these. We get to reduce that, which means this is really just the limit as x goes towards 1 of x divided by negative 4. Well, now we can, sorry, my handwriting got bad there, negative 4. Well, now we can just do direct substitution again. If we do direct substitution on this, we get 1 divided by negative 4, or negative 1/4, and then it's done. So when we got that 0 over 0, we had to do a little bit of factoring on there. Okay. If you're watching this at home, pause the video, try this problem, and then come back when you're done. If you tried this one, you worked on something like the following. If you kind of went through this and you said, okay, well, I'm going to plug in 0 because that's what Alquist said. Just do direct substitution, see what happens. You get 0 squared minus 8 times 0 divided by 0 squared minus 6 times 0. And you realize really quickly that you get 0 over 0 and you go, oh my gosh, that's a hole. I got to fix it. I got to figure something out. Since I got a hole on that, what I really need to do is I need to go, okay, what happens if I take this limit and I factor out an x out of the top and I factor an x out of the bottom, and now beautiful things happen. Those reduce. That reduces to 1. Some people say it cancels out. I say it reduces to 1. It really doesn't cancel. It just reduces. But I think it reduces. And now if I put in 0, I get 0 minus 8 divided by 0 minus 6, or 8 over 6. Or if you wanted to reduce that, we could write it as 4 over 3. And now you're done with that. Hopefully this helps you. Good luck. Ask questions if you need help.